Alright, so continuing on with our lesson on electric charge and static electricity, the distance between two objects also affects the size of the electric force. So, like I was saying before in part 1, the closer together the charged objects are, the greater the electric force is. As charged objects move farther apart, they attract or repel each other less strongly. So now, how can an object become charged? Objects become charged when their atoms gain or lose electrons. And it's extremely important that you understand that it's never going to be loss of protons or loss of neutrons whenever. It's always going to be a gain or loss of electrons. The three ways that objects can gain or lose electrons are by friction, contact, or induction. And contact is sometimes also called conduction. So charging by friction occurs when you rub two objects together, and that causes a transfer in electrons between the objects, and then they're either attracted or repelled from each other in some way. And a good example of this is if you were to take a balloon and you were to rub it on your head, and suddenly the hair starts being attracted towards the balloon and your hair starts sticking up. That is charging by friction, and obviously those are opposing charges because of the attraction between them. How can an object become charged? Continuing, if a charged object and an uncharged object touch each other, then the charged object can transfer some of its charge to the area it touches. So let's just review really quickly. Friction, you take two neutral objects, you rub them together, and they become charged. Contact or conduction, one of the objects is already charged, and you touch a neutral object, and some of the charge gets transferred over to the neutral object. Induction, there's no contact between the two items. So you'll have a charged object and you sort of bring it close to an uncharged object, and what'll happen is some of the like charges, the same charges will move away from that, and it'll make an area of opposing charge. So, for example, if an object with a negative charge is brought near another object with a negative charge, the electrons on on the other object with the negative charge are going to move away, and you're actually going to make a positively charged space. So what is static electricity? Static electricity is the buildup of electrical charge on an object. When something is static, that means it's not moving. And so static electricity is an extra positive or negative charge that builds up on an object until it eventually moves elsewhere. Charges that build up as static electricity eventually have to leave the object because they build up, and they have to leave at some point because there's too much. The loss of charges is known as electric discharge, and this can happen either really slowly or very quickly. So an example of it happening very quickly would be when you see lightning. When lightning strikes, charged particles move towards places with opposite charge. So that's why you can see pictures of lightning striking a building or something like that, or a tree. It's aiming for a high point that has an opposite charge. So what kind of materials affect the flow of charge? So an electrical conductor is a material through which charges can move freely. And generally these will be your metals. Metals are really good electrical conductors. And the example they have here is copper, because copper is used to make wires because it is such a good electrical conductor. When an electrically charged plastic ruler touches a metal conductor, the charge it transfers through the metal can move freely through the metal. So you see, you have your negatively charged ruler, it touches your copper wire, the negative charge immediately flows in and can transfer all throughout the wire, making it a negatively charged wire. Meanwhile, an electrical insulator is the opposite of this. The electrons don't move very freely. They're tightly held in the atoms of an insulator, and the things that act in this way are plastic, rubber, glass, and dry air. Plastic is often used to coat your wires because they are insulators, so that's why you don't get shocked whenever you touch your plastic cord on your iPhone charger, because plastic is an insulator. If it were just metal that were there, you would probably get shocked a lot. And last thing, how is charge conserved? So charging objects involves moving electrons from one object to another. The total amount of charge that you have to start is going to stay the same no matter how many objects you decide to move the charge around to. And this is called conservation of charge. So just like when we had conservation of energy, where you can't create or destroy energy, but you can move it around or make it a different type of energy, the amount of charge you have is never going to change. So if you start negative, and it's like a -10 charge, you're still going to have a -10 charge if you move some of it to a second object. So now both have like a -5 charge, and so -5 plus -5 would get you a -10 charge anyway. And they give you another example. A neutral object may become negatively charged by gaining electrons from the second object. The loss of electrons causes the second object to become slightly more positively charged. So the electrons are not really lost, they simply move from one object to another. And so that is it for our unit on electric charge and static electricity, or for our slides really, not really our unit, because we have more to talk about. More about Ohm's law and about circuits.